Math 3, Unit 1, Section 2. Today we're talking about translations. So remember that translations are where you're going to end up moving things. So it's like we're shifting it right, left, up, down. Sometimes with the translations, you can do reflections at the same time where we reflect it over an X or Y axis. Today, though, we're just going to be talking about moving things. Okay, and so when you see this, so this f of x basically stands for your original function. And if you have a plus a at the end, that means you are going to end up translating it up however many units a is. Okay, and so if you have a minus a, that means you'll end up translating it down. Good. Okay, this is where it's kind of, you just have to remember something here. And that is when you have something in parentheses, do you remember when you would solve equations back, in Math 1 and Math 2? And do you guys remember factoring? Like if you had something like this, like x plus 3 and x plus 2 in parentheses equal to 0. And then you would set each of those parentheses equal to 0. And so you would actually end up getting x equals a negative 3 and x equals a negative 2. Do you guys remember that? And if you're not sure how I got that, it's just like x plus 3 equals 0. And so I'd subtract 3 to both sides to get x equals negative 3. Does that make sense there? Okay, so when you have the parentheses here with the x plus a, that means you're actually going to end up shifting it left instead of right, because it really means when you take it out of the parentheses, it's going to give you a negative value. And so this will be a left a, which means that x minus a would end up translating it right is correct. Okay, questions up to this point? Are we good with this right here? Okay, so over here to the right, it says sometimes we have to use our algebraic skills to get an equation into the form that helps us to graph it correctly. Practice here with this equation and convert it to y equals f of x. Basically what that's meaning is you just want y on the left side and everything else on the right. And so in order to get y by itself, what would I need to do first in this equation? Very good. The first thing I would need to do is subtract 2x. So I'm going to subtract 2x to both sides. So when I do that, the 2x and the negative 2x eliminate. Be careful that you don't lose your signs. So I still have a negative 5y equals, and how would I write the right side of the equation? Perfect. Negative 2x plus 15 is correct. Is y by itself? No. So the next thing I would need to do is what? Very good. Divide by negative 5 is correct. So I like to divide by negative 5 to every term so that I don't forget to put the negative 5 with something. Okay, I know some of you write a whole line and put negative 5, and if that makes sense to you, that's totally fine, but just make sure the negative 5 is going to the negative 2x and also to the 15. So when I do that, the negatives cancel and the 5s cancel, and I'm left with y equals, 2 negatives here make a positive, so I write this as 2/5 x, keeping the number in front of the x. And then 15 minus 5 is what? 15 divided by negative 5 is, good, negative 3. And so now it's in the correct form. Okay, and so if this was my original function, there's nothing in parentheses with the x being added with it, but at the end here it has a minus 3. Okay, and so that means this graph, which way would it end up translating it if I was moving it? It's going to move down 3. Okay, so whatever's being added or subtracted at the end, that's moving it up and down, and anything that's in parentheses with the x is where it's shifting it right or left. Okay, So looking here, we're going to actually come back to this one. We're going to start here with our lines, okay? This first one right here, this is the equation f of x equals 3x, okay? This, in the description box, I want you to write this, that these are our parent graphs. These are the original functions. So if you want to write here original function, if that makes more sense to you, you can do that. Okay, so this line right here is f of x equals 3x. And remember, you can think of f of x as y. So this is the same thing as y equals 3x. So now what they're saying right here is we have y equals 3x plus 3. So what am I going to do with that? Move it up 3. And so when you're translating functions, what you want to do is, if you have points that are already on that graph, I just take each of these points and I translate them up 3. So from here, I'm going to go up 1, 2, 3 and make my new point. From this point right here, I'm going to go up 1, 2, 3, make my new point. And then we draw our new line. And you could use your ID card, or I have rulers over there in those brown little, just so you know. If you like things to be perfect, there are rulers right here. You are welcome to grab one if you want to. You can go right now during notes. It doesn't bother me. Okay. So here we have our quadratic function. Again, this is our parent graph. And then on this one it says plus 3. So all we're doing is we're taking this graph and we're going to translate it up 3. And so we're going to do the same thing. So we're going to go to each of these points on here and we're going to go up 1, 2, 3, up 1, 2, 3. And we draw our new quadratic function that has translated up 3. Same thing now on our absolute value function. We are going to translate it up 3. And on your exponential function, translating this one up 3 as well. Now there's one thing you have to think about on the exponential function that we didn't look at on the other one. And what is that? Asymptote. Very good. This has an asymptote. And so as I translate this one up 3, you are also translating the asymptote up 3. And so right now, where is my asymptote at on this graph? 0. And so we're going to move that up 1, 2, 3. And so we need to make a asymptote right there. And asymptotes are dotted lines because they're not actually a line. It's just letting you know there's a boundary there so that this graph cannot cross that line. Okay, and so the description of what has happened with all of these graphs would be that they did what? Okay, and we're going to write this a couple different ways. So let's write this in words first. Translated up 3. Another way you're going to see it written is with the T standing for translation. And I'm not sure what that's called. Does anybody know what it's called? It looks like a less than sign, but yeah, whatever. So that symbol. And then it didn't change on the x-axis. And so it's a 0 in the spot where you would write an x because we did not translate right or left. And then in the y part, it translated up 3, which is a positive 3. And so you will see it written like that. Okay, any questions? All right, this next one. Oh, and you know what? Let's go back to this f of x plus 3 here. Same thing on this one, right? Can you guys do this one? So we're just going to move each of these points up 1, 2, 3. And so just kind of try your best to copy how the curves are. Okay, as we go through this, we're not going to end up doing every single example on these because we can see that we're just kind of doing the same thing over and over again. So hopefully we're okay with that. But on this next one, do you know what we're going to end up doing? Okay, we are going to translate down 4. So let's go ahead and just look at the absolute value and the exponential on this one. And so all you're going to do is take each of those points and move them down 4. 1. Okay, I'm going to give you a minute to try the exponential function on your own. Make sure you also translate your asymptote. And then check in your groups to see if you guys got the same answer. Okay, so we should have moved each of these down 4. 1, 2, 3, 4. Where is your asymptote at? So it's at 0, so that means it's going to move down 4, so it should actually be at -4. And specifically, what is that, when that line, that's at y equals -4, correct? And so if you want to put a little note to yourself to remember that that is y equals -4 up here, this one was at y equals 3. Okay, any questions? All right, let's move on then. Bless you. Okay, so let's go to the description first, because we have to know what's happening. Oh, did I forget? We forgot to write this one. Sorry. How do we write this one in the other form? So T, and like our less than sign, what's going to go in there? Did we translate it all on the X? No, so that X part will be 0, and then the Y part will be good. Okay. So what is going on with the top example? How do you think that is going to translate? Okay, so remember that when you have something in parentheses like this, the absolute value, you can think of that as parentheses. Here, even though it's not in parentheses, you see how it has the x plus 4 together in the exponent. Whenever you see something in the parentheses, you would set it equal to 0, which means you're going to get the opposite value that you see. And so in this case, we're going to end up translating which way? Very good. Left 4. And let's go ahead and write it the other way. So we're going to go t, and then what will I write for the x part? A -4. And then is it going to translate it all in the y? No, so that's going to be a 0. Good. Okay, so let's go over to the line this time. Let's do the line. And what am I going to do? Good. So just each of these points, we're going to move to left 4. 1, 2, 3, 4. 1, 2, 3. Okay? And then we can draw our line. Okay, the parabola, how is that one going to translate? Same thing, right? Left 4. Now, if you go over to our exponential function, will the asymptote change on this one? No. So let's go ahead and translate this one. So we're going to go left 1, 2, 3, 4. So the asymptote is still there. Again, it has just moved left. Any questions? Okay, next row down. How is that one going to translate? Very good. So, translate right 3. And how would we write that one? What's going to go inside? Positive 3, good, and 0. Okay, so go ahead and choose 2 graphs. I'm going to give you 1 minute to do that, and I'm just going to walk around. You can even do the function one at the first part. Does anybody have questions right now? Yeah, just Okay, so I'm just going to go ahead and do the absolute value one here. And so I'm going to go right 3. So I'm just moving each of these points to the right 3. Okay, any questions? All right. So this next one, we're going to go ahead and do all of the examples on this row. But let's talk about what's going to be happening here. So if we look here, in the parentheses, we have a plus 3. So that means we're going to end up doing what? Left 3. Good, because we set that equal to 0, we get a negative 3. So let's write this down. So we're going to translate left 3, and what does the minus 2 mean? Very good. And down 2. And so when we write this out, we have our t. We use our less than sign. I need to figure out if there's another name for that. And what will I write inside there? Wait, okay, what does left 3 mean? Negative 3, because left means you're going to the negative side, correct? And then down 2 would be a -2. Very good. Does anybody have questions on that piece right there? We're okay? All right, so let's start with the line and let's translate that. So starting with this point, I'm going to go left 3, 1, 2, 3, and down 2, 1, 2. I'm going to go up to this other point, and I'm going to go left 1, 2, 3, down 1, 2. And then draw my line. Okay, let's do the same thing with the parabola now, or the quadratic. So we take this point, I'm starting with my vertex. You can start with any of the points though. And I'm gonna go left 1, 2, 3, down 2, 1, 2. You mean this 2 right here?
Yeah.
That is letting you know it's a quadratic function. So this right here is dealing with the squared, because you know when you have a number inside, you square it, and that's how you get these points on both sides, and it's a symmetrical graph. And so we know this is the quadratic function, and so all we're doing is taking our original graph and just moving it. Okay, and so then each of these points, I'm going to go left 3 and down 2. Okay, we'll move on now to the absolute value. Left 3 and down 2. Okay, your exponential function. The first thing I might even do is move my asymptote if it's necessary, just to make sure I don't cross that line. And so where will my asymptote end up moving to? Good, just down 2. That one we only have to worry about the y. And so what is that new asymptote at? Good, y equals -2. And then we'll go ahead and translate these points. So we're going left 1, 2, 3, down 1, 2. Okay, and I think the most tricky one is the function over here. And so let's go ahead and give that one a try too. So left 3, down 2 with each of those points. And you could even do like two points, draw that piece of the graph, and then draw your next, or plot your next point and draw that part of the graph. Any questions? Okay. This next one, we're going to use the domain and range. We're going to talk about the domain and range, and then also with the function. So before we do anything though, we need to talk about how these graphs are going to translate. So, how are they going to translate? Okay. So with the parentheses, what's with the x? When we set that equal to 0, that means it's going to end up +4, which means it would go right 4. Thank you. So translate right 4, and then what? Up 2. Good. And so when we write that for translating, right 4 is dealing with your x value, right? And so is that a positive or a negative? Positive 4, and then up is also positive, so a positive 2. So that's the translating that's going to happen here. So let's start with our line. And when we're giving the domain and range here, we are just going to give the domain and range for our new function that we've translated. Okay, and so we're going to go right 4 up 2. Okay, so don't worry about the black graph. We're only looking at the purple one here. And so if you still have your cards, you could take this out and look. So for the domain, remember domain is our x. And if you forget, we can put like an x by domain and a y by the range. So since there's an arrow there with the x, that means it's going to start at what? Negative infinity. And then as it continues on, it has an arrow at the right side of the graph, which means it's going to go to positive infinity. And again, in our notes, I want us to write it in both forms. Yes?
If there was an open circle in that, would I write that down?
Yes. Then we'd have to like make a stop and do a union. Okay? So we're going to also write this in our inequality form. And so that would be negative infinity is less than x is less than positive infinity. Okay, for your range, if we start going down, looking at the purple portion of the graph, we have an arrow going down, so that means it's starting at negative infinity. And as we go up, we can see that it goes with an arrow pointing up, which means it's going to go to, good, positive infinity. And if we write that in inequality notation, that is negative infinity is less than y is less than positive infinity. Questions there? Okay, let's translate our quadratic function now. And so again, if you ever forget, you can always kind of look back, but we know whatever's in parentheses means we are going to do the opposite of what's there. So I'm going to go right 4, 1, 2, 3, 4, and up 2. Okay, so with each of the points, okay. So domain. Looking at that graph, what is my domain going to be? Good, negative infinity, because there's an arrow on the left side of the graph. And then as we go through, there's an arrow at the right side of the graph. And so my domain is negative infinity to positive infinity. The inequality notation, negative infinity is less than x is less than positive infinity. Range, starting at the bottom of the graph, what is that starting point? 2 is correct. And will I use a bracket or a parenthesis? A bracket. And why am I using a bracket? Very, very good. Closed circle, it is equal to 2. And then as we go up, there's arrows pointing up, so that means it goes to positive infinity. And do I use a bracket or a parenthesis? Parenthesis, good, because infinity never has an end. Okay, and so when we're writing this one in inequality notation, how will I write it? Good, 2 is less than or equal to y, and why do I have that equal sign underneath? Because it's equal, closed circle, good, is less than positive infinity. Okay? Why don't you guys give the absolute value you want to try on your own? Okay, so can someone tell me what my domain is for my new function? Good, negative infinity all the way to perfect. And we know that that one in inequality is negative infinity is less than x is less than positive infinity. Okay, can someone else tell me my range? What is my starting point on the range? 2, and is it a bracket or a parenthesis? Very good. So we have, bracket 2, and it goes all the way to positive infinity. And in inequality, that means we have a 2 is less than or equal to y is less than positive infinity. Okay. Questions? All right, we're going to go ahead and translate this one as well. We're going to go, what am I going to do with my asymptote though? Thank you. Good. Move my asymptote up 2. So I'm going to go ahead and let you guys finish this one on your own and go ahead and translate your graph and write your domain and range. Okay, did you guys finish this one? Okay, what is my domain on this function? Good, negative infinity to positive infinity. Okay, again, if you're going left to right, you can see an arrow is pointing to the left, so that means on the domain it's going to negative infinity, and as it moves, there's an arrow to the right of the equation, so it goes to positive. And so that in inequality, negative infinity is less than x is less than positive infinity. What is my range on this one? So the range as you're going up here, right? It's starting here at the asymptote, which is at 2. Will it ever equal 2? No. And so that means we will use a parenthesis 2, and then as it goes up, again, there's the arrow going up, and so it goes to positive infinity. And so that means we have this as 2 is less than y is less than positive infinity. And I think our function over here is a good one for us to do and practice our domain and range on that one. Although there's no open circles, so it won't be too bad. But again, let's move each of these points. So we're going to go right 1, 2, 3, 4, up 1, 2. Right 1, 2, 3. So I'm just going to take it one piece at a time so that hopefully I don't get too confused with the overlapping of graphs. Okay, the next one, right 1, 2, 3, 4. Up 2. And then we have right 1, 2, 3, 4, up 2. It's kind of off the graph there a little bit. Did I do something wrong? Okay. All right, so domain. There's no arrows on this one, so there's endpoints, right? And so what is my smallest x value? 1. Is it equal to 1?
Yes.
So I'm going to use a bracket. So we have bracket 1. Everybody good with that? Yes, Denise. So remember that domain is dealing with all of our x values. This right here is my x-axis. And so I'm only looking at the points on the x-axis. And so if I take my card here and I'm going and I find this one point right here, that is the smallest point on the x-axis. And if you go down here to the x-axis, it is at the value of 1 on the x-axis. Okay? Then as I move this card along, keep going, this is where it's ending. And it's off the axis or off our graph right now, but we know we went off 1, 2 points. So right here, what is this point on the x-axis? 9. And so that means it went from 1 all the way to 9. And did it equal 9? Yes, so that means I use a bracket. Okay, please make sure you're not on your cell phones. So, yes.
Why didn't you use the other 2 points?
I don't know this. How come I didn't stop at those points? They're not open. They're closed circles. So remember that when you have closed circles and you have points, it's fine. You just keep going. Okay, so we're only looking for when it doesn't equal. Does that make sense? Yes, Denise. How can you tell when they're equal to each other? Oh, because it's a solid, it's like a filled in point. And so remember when you have the points on the graph where it says it's not filled in, that's when you use a parenthesis because they're saying it's going to stop at that point, but it never actually touches that point. Okay? Are we good? Kind of. Let's practice with the range, and then we can always come back to it again, okay? I can go backwards at any time. Okay, so over here, if we're looking now, range is y, correct? So y is our up and down values. So if we take our cards, and I can hand out more cards, again, if you want them, if you didn't save yours, I'll pass those out here in a minute. But if we're looking at our graph, this point right here, that is the smallest y value, okay? So and this is what you have to be careful of. Where is this hitting the y-axis? Because our range, we're only writing the y value.
0.
It's hitting it at 0, okay? And it's going to be a bracket because it isn't an open circle. So that's at 0. Thank you. Does that part make sense? So remember that every ordered pair has an x value and a y value, correct? And so when we're writing domain values, we are only taking the x value of those points. When I'm talking about the range, I'm only taking the y values of that point. And so when I'm going up here and I'm looking at the range, the smallest range value was at this point, and that on the y-axis is at 0. Okay? As we go up, we keep going, and there's no open circles, so I don't have to worry about anything, even though there's multiple areas right here. All of them there's nothing that's an open circle, and we keep going up. And right here, this is the largest y value. Okay? And so this point has an x and a y value, but we're only writing the y for the range. And so the y value at that point is at what? 4. And it's a filled in circle. It's a solid circle, and so that's why I use the bracket. Had there been an open circle on the graph, then I would write the parenthesis. Okay, do you want me to talk about something here again? Or try to re-explain something? You got it? Good. We'll keep practicing. Okay, and so inequality form on this one. 1 is less than or equal to x is less than or equal to 9. And on my range, 0 is less than or equal to y is less than or equal to 4. And why did I use the equal to signs on this one? Because it's brackets, because all of them are equal to. There's no open circles. All right, any questions?